Hi, everyone. We'll give folks a couple of minutes to join before we get started. All right, folks, we'll go ahead and get started here. Thank you all for joining our Conjoint simulator training. My name is Alexa Marion. I lead the user experience team here at SightX, and I'm also joined today by Jean Bruzy, who is our data scientist. So today we're first going to review what is a conjoint analysis. Then Jean is going to review building a conjoint experiment in SightX, as well as analyzing your conjoint data in SightX. After that, we'll do some key takeaways and some Q&A at the end. So first, what is the purpose of a conjoint experiment? Conjoints are used to uncover consumer preferences about your products to predict product adoption, gauge price sensitivity, choose the optimal set of features for your products, and to project market share. So the most popular use for conjoint analysis is typically within product development, so helping brands find the perfect set of product features and messaging points for their target markets. Conjoint analysis is generally really versatile. It can be used across most industries for products ranging from vacation travel packages to consumer packaged goods. So how is a conjoint experiment conducted? First, you'll break down your product into the characteristics that differ between product variations. SightX will create a set of products for every possible combination of characteristics, and then respondents will take your survey and choose which product in a set they prefer. This is repeated across several sets of products. So you can see in this screenshot at the bottom, here we have 3 products pictured, and those products differ in each flavor, volume, and price. And so respondents would go through several sets of these and choose which of these products they prefer. Jean will go over this in a little bit more detail, but just wanted to showcase that to get everyone oriented here. So once respondents have taken the survey, SightX reviews the data across all of those respondents and calculates the overall preferences of the group, which enables us to provide you with static reports as well as dynamic simulations. So what can you learn from a conjoint experiment? First is level and attribute importance, so you can understand how the different features of your product influence consumer choices and which features are most attractive to your audience. Next is segmentation, so you can identify product variations that resonate with specific clusters of your audience. And finally, you can learn more about demand, so finding the market share of products of interest that you're considering developing, and then you can simulate how their demand is affected by changes in price. So now I'm going to turn things over to Jean to review how to build a conjoint experiment in SightX. Jean, you might be on mute. Is anyone else having trouble hearing? Oh, give us 1 second here, sorry. Okay, apologies there. Going to turn back the video a bit. And John, if you want to get started, you should be all set now.
Thanks a lot, Alexa. Hello, everyone. Thank you for coming today. My name is Jan, and now I'm gonna go over how to create a conjoint experiment in SightX. So let's start with an example. So let's say we're a soft drink company considering adding a lime soda to our product offerings. We want to evaluate how the new flavor will impact sales of our current product portfolio and how it will perform against the lime sodas our competitors have on the market. The in-survey experiment shown to respondents could look something like this, where we ask respondents to select the soft drink they like the most. To run a conjoint experiment, start from the Create page of a project. Choose Conjoint in the Methodology section and add the conjoint experiment to your survey. In the initial experiment setup, first give your experiment a title. The title won't be shown to respondents. It is just used for a reference in the case that you have more than one conjoint in a project. Next, write the introductory description of the experiment that will be shown to respondents in the survey before the conjoint questions begin. So here we can add a description to them. Finally, write a prompt that will be shown with each set of choices. It is important to specify that respondents should choose their most preferred option. So here we add a question for them. Next, you will input your product variations and configure any restrictions you may have. In a conjoint experiment, your product or service should be broken down into attributes. An attribute is a specific characteristic of your product. Using our soft drink example, our attributes could be flavor, price, and volume. The attributes you choose should be characteristics that vary across your product portfolio and those of your competitors. Let's start with your flavor attribute. So we set up the flavor name. In SightX, there are three types of attributes. We have categorical, numeric, and prices. Categorical variables are things like flavor, brand, and color. Numeric variables are things like volume, length, and weight. Anything with a numeric measure in units other than price. Prices are just that, variables for the cost of the product. It is important to differentiate between numeric and price variables because only price variables can be used to calculate elasticity and expected revenue in SightX. Our flavor attribute is categorical. Now, we will define the individual levels within this attribute. Levels are the potential options an attribute can have. So, for our flavor attribute, we use the labels lime, cola, orange, and ginger ale. Lime is included as the potential new flavor we are testing, and we have included the other flavors of soda we currently sell to determine the share of sales the flavor will have if we introduce a new one. So, let's start by writing these labels below our flavor attribute. Here we can see we put lime, we put cola, we put orange, and finally we define ginger ale as the labels for flavor. The next attribute we're going to add is volume. Because bottles of soda can have different sizes, volume is measured in liters, so it is a numeric variable. So let's add a new attribute. Let's define the name as volume. Let's select numeric as I'm showing in here. Now, we need to think about the different levels our volume attributes can have. So for example, our brand only sells 0.5 liter bottles, but our competitors sell lime sodas in 0.75 and 1 liter sizes. Since we want to see the market share a lime soda will have amongst our competitors, we will include the sizes they sell as well. So here we define the sizes. And also we need to specify the units as being liters. The next attribute we will add is price. Testing a price attribute allows you to use the conjoint to measure the demand of your product and to understand which product characteristics consumers are willing to pay more for. We will select our currency and enter the prices we could reasonably sell our product for and our competitors' prices. So here I select price, I put the 9 tag, I select in this case US dollar, and then I input the prices. Let's use 80 cents 65 cents and 50 cents. So we expect our drink to sell for those prices. Here, we will also specify that our price attribute is order, meaning that some levels are more attractive to consumers than others. Price is a good example of an order attribute because in almost all cases, lower prices are preferred by consumers. When order is turned on, we need to make sure our levels are arranged from worst to best, as indicated by the scale on the right. We have added our attributes so far in a way where any combination of flavors, sizes, and prices can be shown to respondents. However, there might be certain products that don't or cannot exist and shouldn't be tested with respondents. To handle this situation, we can add a conditional attribute, which is an attribute whose levels depend on the levels of another attribute. For example, we may have the scenario that higher volumes of soft drinks cost more to produce, so higher volumes should not be paired with lower prices. To do this, we have actually going to create a new price attribute as a conditional attribute. So let's add this conditional attribute and let's set the price and let's choose price as the category of the attribute. First, we will select the independent attribute, which is the attribute whose values will define which level of the conditional price variable will be shown. In this case, the independent attribute will be volume, since the volume of the product determines the possible prices. Once we do that, a table will appear with the levels of our independent variable, so that we can define the levels and values for our conditional variable. First, we will define the levels for our price variables. For every size soda, we want to test a low, a medium, and a high price, where the actual prices shown will differ based on the size. So let's set the high price, the medium price, and the low price. Now, we will input the high, medium, and low possible prices for each volume. This way, we can ensure that the products presented in our test reflect the actual products that we or our competitors could sell. So, we expect the low volume to have lower prices than the higher volume. So, let's start with a high price of 70 cents up to 50 cents, and then go up as we increase the volume of our products. So, as you can see, this will be the prices that will be shown to respondents when they see the products that they can select. Now that we have configured all of the attributes and levels that we want to test, we could be finished defining the experiment. However, we are going to take a quick look at the advanced configurations options available in SightX. We may want to allow respondents to answer that they wouldn't prefer any of the products shown in a set by providing them with an opt-out option. It can be beneficial to allow this so that you are not forcing respondents to choose a product when they dislike all of the products displayed. However, respondents who get fatigued taking the survey might overuse the opt-out option. So you should use it carefully and you should know your audience. So let's activate the add none of these option. And this will be the opt-out option. Now, let's look at pairs to exclude, which you can use to prevent certain pairs of levels from appearing in products together. For example, maybe we don't have an orange soda currently in our product line at 0.5 liters. To create the exclusion, we will select the flavor and volume attributes under pairs to exclude. So let's select the flavor and the volume. And then we are going to select orange at 0.5 liters. So this will prevent this pairing from occurring in our products. You can also define full products that shouldn't be shown in the experiment under products to exclude. For example, let's say lime flavoring is expensive. So lime soda is never sold at the highest volume and the low price. Here we can add that product to specify that it should definitely not be shown to respondents. As you can see, it's pretty straightforward in SightX. Finally, it is also possible to define products that must be included in the test. For example, we could specify that the new lime flavor we are considering must be shown with the 0.5 liter volume and the high price, at least one to each respondent. As we can see, it's pretty straightforward to add this. We advise that you only use these advanced options if absolutely necessary, as they can cause labels to be shown an unequal number of times. This can cause results to be biased towards the labels that are shown more frequent. Now that we have defined all of the product inputs of our experiment, it's time for SightX to actually create the product combinations that will be tested with respondents. Click on Generate Products, then Proceed to confirm you are completely done with the attribute definitions. After that, you can let SightX define the number of products, or you can define them yourself. So we give you this flexibility. The process is complex and can take several minutes, so feel free to continue building your survey while the experiment is being generated. SightX will notify you when this is ready. So let's define the number of sets in this case, and also let's define the number of products per set that we expect to show to customers in this case. As you can see, this process takes a while. We will let you know that we are generating these products and these sets, and we will also let you know when this is ready. After you finish creating and testing your survey, you will distribute it to respondents to participate in the experiment. In the next section, we will review the results of our experiment and see how we can use them to make decisions around our new lime soda product launch. Let's continue to how to analyze the results from the conjoint experiment. So, once you have finished collecting responses to your survey, now the results are ready to be analyzed. First, we will review the basic results of the experiment, which labels are most preferred and which attributes are the most important to consumers. After that, we will dive into our conjoint simulator, where we can identify optimal products and their target markets, view market share, and calculate demand curves and product elasticity. To begin reviewing conjoint results, navigate to the Question Analysis tab in the Analyze section of the project. The first output we will look at is the level performance graph. This shows how much influence each level has on respondents when they make decisions. Levels with higher absolute values, distances from zero, are the most influential in decision-making, while those with values closer to zero don't have as much influence. Here we can see that the flavors cola and ginger ale are the drivers of product selection, with cola being the flavor that most influences consumers to choose a product. The other two flavors, lime and orange, are the least attractive one. The very soda sizes all have performances close to zero, meaning that they were not very influential in respondents' choices. We can see that the levels that were the most influential overall were the low and high prices, with the low price being the most positively influential characteristic and the high price being the least attractive characteristic. Next, we will look at the overall importance of the attributes, where we can see how influential each attribute is in consumer decisions. We can see that consumers are influenced the most by the flavor and price of our proposed sodas, while volume did not factor very much into their choices. The level performance and attribute importance give you an overall idea of consumer preferences, but they only show a fraction of the insights that you can get out of a conjoint experiment. To enable you to fully take advantage of our conjoint experiment, SightX offers a simulator for you to take the most out of your data. Click the Go to Simulator button or click on Simulators on the left side menu and select Conjoint. In our Conjoint simulator, you have access to two powerful tools, the Segmentation tool and the Demand Simulator tool. First, let's look at segmentation. By default, SightX creates a segmentation that includes all of the respondents in your study. You can create additional segmentations using a filter set of respondents, but for now, we will review the default segmentation for all respondents. In the segmentation, you will see your population divided into groups, called segments, that are clustered around the predicted preference for a potential product. These segments can be used to find product combinations to produce, and to determine the target market for various products and levels. The more segments you divide your population into, the more reliable the predicted preferences of each segment are. However, having many target consumer groups typically involves a lower overlap in the preferred levels of each group and can make it difficult to determine the meaningful differences in segments. By default, SightX indicates an optimal number of segments, which is the fewest number of segments that will still meet or require a level of confidence in the accuracy of the preference and the predictions for your experiment. We will mark this with the word optimal. In our experiment, the optimal segmentation is two groups, one comprising 81% of our population, who prefer cola flavor, 1 liter volume, and the low price point, and the other comprising 19% of our population, who prefer the lime flavor, the 0.75 liter volume, and again, the low price point. Below the segments, we can view the level performance and attribute importance for each individual segment. Use the drop-down to change between segments or view all segments at once to see the data for the total population. Based on our analysis and segmentation so far, we can see that we have two distinct groups of consumers, those who prefer cola flavor and those who prefer lime. While their volume preferences differ, we know that the volume attribute is not very influential in their soda purchases, so we can choose to focus on the flavor as the differentiating factor. Once you know which products and levels you want to focus on, your next question will probably be, who are the people who make up each segment? Knowing the demographic skew of each group allows you to understand the target market of each product of interest. To learn more about the people who make up a segment, click the magnifying glass on the segment card. Doing so will take you to the question analysis dashboard, where you will see the responses to the rest of the survey questions. Filter for that specific segment. However, the easiest way to spot differences in the demographic makeup of each segment is to compare the responses of all of the segments at the same time. We do this by clicking the View Segments button. We can see some skew for males towards segment 2, the group who prefers lime, and for non-binary folks towards segment 1, who prefer cola. But scrolling down to the age demographic shows an even clearer skew. Segment 1 cola are all on the younger side, while the segment 2 lime preferers are all about the age of 41. This clear data on the differences in who makes up your segments allows you to make better decisions about marketing resources, as well as understand portfolio cannibalization as you consider which products to launch. Navigating back to the Conjoint simulator, let's review how to use the demand tool to examine individual products and product portfolios to determine market share and elasticity. So let's start a new simulation. Each demand simulator you create revolves around a specific set of products. So you will first need to define the products you are interested in analyzing together. This will differ based on your goals. You may want to see how a potential new product will impact sales of your existing product portfolio, or you may want to see how it will fit in the market with your competitors. Let's say we want to see how our lime soda will compete against our competitors. To do this, we will create our competitors' lime sodas, as well as the lime soda we're interested in developing. So first, let's define our lime soda. It's the lime soda at 0.5 liters, the medium price. Now let's define the products of the competitors. As you can see inside it, it's pretty straightforward to create this product. Simply open the drop-downs and select the levels of each product. You can change the names of the product. In this case, we're going to name the first one our product, and then we're going to name the other ones as the products of the competition. Let's calculate the demand of this product. When we click Calculate Demand, the market share will be calculated for the products when consumers are presented with a choice between these products specifically. Here we can see that our lime soda will capture almost 50% of the market at the 0.5 volume and medium price. Now, we can adjust the levels of our product to see how product variations perform on the market. Again, this is pretty straightforward by configuring the levels of our product in the menu above. So let's change it to the medium, to the low price and see what happens. For example, we can see that the change in demand is quite large if we change the price to be low. In this case, the demand for a product is 80%. If we want to change the product set entirely, say to test our lime soda against our existing flavors, we can create a new demand simulation from the simulator dashboard so that we don't lose the products we have already created. So you can create as many as you want. If you have a price attribute included in your experiment, you can also analyze the demand for products at different prices and calculate elasticity and expected revenue. Here we can see the demand curve for each product when it is competing with only the other products in the simulation set. When we view a product, we can see the demand curve and how market share decreases as prices increase. We can also see the demand and elasticity over a specified range of prices. For example, let's change it from 50 cents to 60 cents. When we specify this price range, we find that elasticity is 1.9 and our product is elastic within that price range. Price elasticity is greater than 1, indicate that changes in price within the range will have significant impact on demand. While elasticity is less than 1, indicate that changes in price won't have a significant impact on demand. The higher the elasticity, the greater the change in demand will be. If we scroll down, we can also simulate our expected revenue by entering the expected number of consumers in the market and considering the revenue maximizing price shown in the table below. We can see the total expected revenue of this product considering a market where the only products available are the ones we have created in this simulation. So here, let's change the expected number of customers. You can also use filters to study how different population segments behave. Click on the toolbox on the right and define your filters. For example, let's have a look at our male population. So let's define our filters and then apply. Here we can see that the market share changes slightly. And we can also have a look at how the demand curves are changing. So let's go to our demand curves. We can also see a slight change in demand. We can also filter based on our segment. Remember the segmentation tool? We can also filter by these segments and see how market share and demand changes. So let's choose conjoint segmentation. Let's choose our segmentation, and then let's choose the first segment. In this case, we see that the market share increase for segment 1, and so on. Now, let's select the second segment and see what happens. The demand for a product changed significantly, so we know that segment 2 will be a good target market. Now, you can do much more with our conjoint simulator, but thank you for listening, and now let's go to the QA part of the seminar.
All right, thank you, John. Now we'll do a little bit of Q&A. So if anyone has questions, go ahead and post those in the little Q&A Zoom chat. And I'll do a little bit of moderating here and go through these questions. So Jean, one question we have is how many levels of each attribute can be tested?
So currently at SightX, we can test up to 15 levels per attribute and up to 15 attributes as well.
What should the sample size be for my conjoint experiment?
The sample size actually depends on your, on how many levels you have. Will also depend on how many products you have. So we actually have a calculator in the SightX, in the SightX blog page and blog. So you can use this calculator in order to calculate this the sample size. Usually, if you have around a maximum of 7 levels per attribute, and you use about, let's say, sets of 3 and around 7 sets, we expect around to have a sample size of 250 responses, more or less. But again, you can go to the SightX blog post and then to the resources for Conjoint, and then we offer you a calculator to calculate this.
Okay, great. How are the products defined that are shown to respondents?
This is a very good question, actually. So when creating the product, we have to make sure that we display each level an equal number of times. I mean, each level within an attribute, because if you have attributes with more levels and attributes with less levels, then this will influence how many times each level is shown in the product. But within each attribute, we have to make sure that the levels are shown equally. We also have to try to show each combination of levels an equal number of times. This can be more difficult because, if you have number of levels that are not kind of similar to other number of levels in a different attribute, it can be very difficult to achieve this. This is actually called an orthogonal design. Creating orthogonal designs is actually an NP problem. It's very difficult, but here at SightX, we use an algorithm that was proposed by Shu. We also offer all of the papers that we use in our technical documentation for SightX. So if you want to see all of these papers, you are more than welcome to go to the Knowledge Hub, and you will have access to all of these papers. But the idea is to, generate the number of levels, generate the number of combinations of levels an equal number of times, and then present these products to consumers.
Got it. Thanks. We also have a question. How are we able to incorporate competitor brands into the survey in terms of competitors, pricing, volumes, and variants?
Absolutely. Very, very good question. So one of your attributes in this case should be brand, right? So in the brand attribute, you can include your own brand and then the competitor's brand. So for example, for sodas, maybe your Pepsi, you can include Coca-Cola, Dr. Pepper, and so on, such that in the survey, you capture what people think about these different brands, right? So in the survey when you're creating the survey, you must include your brand, the brands of the competition, the volumes that are used by the competition, also your own volumes, and also you should include the prices that you see in the market, such that when SightX creates the product, we also create the products of the competition. And then when we show these to respondents, then you can capture, okay, how liked is this other brand compared to my brand and compared to the other brands in the market. So when you create the survey, you need to include also the competitors' brands and the competitors' options in the survey. And this way, when you do the simulations, then because we have captured what people like and dislike from the other brands, then we can calculate the share of preference. It's also specified by Allen in here. Yeah, sometimes it might be kind of misleading or confusing to use market share. It's better to use share of preference, but in this case, sometimes it's easier for users to understand market share.
Got it. Okay, thanks. So in summary, because I think this is an important point and a good question, for incorporating competitor products, you need to make sure that you're setting those up at front in the experiment to make sure that the product set is capturing the actual products on the market. And then you're able to, again, access those in the analysis and in the simulators, correct? Great. And then we have a question here. How many products can we simulate at one time?
At the moment, there is no limit, so you can add as many products as you want. I mean, the limit is the number of products that you can create with your attributes and levels. But yeah, there is no limit in the number of products that you can simulate.
Can the levels have images associated with them?
Yes. So when you are creating the conjoint experiment, you can add images to each level, and these images will be displayed in the survey.
And just a couple admin items. Yes, we will be sending out the webinar to everyone in attendance. I think we can also include that blog link that Jean mentioned with the sample size calculator. And I know we've had a few sort of more specific questions. We'll make sure we're following up with folks about those because I know there's been a lot of interest in a couple of things here. Before we wrap things up, we do have time for a couple more questions, if there are any others. If not, as I mentioned, we'll be sending out the recording, following up with a couple of folks individually about specific questions. But of course, as you can see here, we have plenty of support resources, both in our support site, as well as you can contact your CSM or other SightX rep if you have any questions, want assistance setting up your first conjoint, or anything like that. So yeah, thank you all so much for joining our webinar today. This has been great. Thank you so much, John. And we'll talk to you all soon. Take care.
Thanks, everyone.
Bye.
Bye.